Welcome to RT3, Right Triangles, Unit 3. In today's lesson, you are going to learn what sine, cosine, and tangent are. You will also learn and be able to determine side lengths and angles using the trigonometric ratios. Before we get into this lesson, we need to think back to the ancient Greeks. And back in January, we talked about some special right triangles where, for example, when we had a right triangle in the 30-degree angle here, we found out this special relationship where this length was 1 and this length was 2. And if I had a bigger 30, 60, 90 triangle, and let's say the short side was 2, what would happen to the hypotenuse is it would be 4. Same thing if I had an even bigger triangle where the short side was 3, then the hypotenuse would be 6. So these ancient Greeks had figured out that the ratio here was 1 to 2. And this back then was very profound. They were really excited, they loved using it, but then somebody came along and realized that because, they didn't have the internet, they didn't have anything else, they just had the math, and they looked and they wondered, okay, well, what happens if on our triangle, instead of it being our 30-degree angle, what happens if it's actually 29 degrees? And if that side length is still 1, they wanted to know, okay, what's the ratio? And they actually figured out for every right triangle, given an angle, another angle, you can find the ratios. Now, I'm not going to make you memorize every single one because that would be a lot, right? Actually, your calculator can do them for you. Back in the day, people had to actually look up each one. There are 3 basic trigonometric ratios that you need to know, and they are sine, cosine, and tangent. They're abbreviated as sine, S-I-N, cosine, C-O-S, tangent, T-A-N. And yes, you can use those abbreviations, and you should use the abbreviations. Notice when I said each of the abbreviations, I still said the word. So instead of saying sin, cos, tan, I said sine, cosine, and tangent. And you have these buttons on your graphing calculator, and that's what they stand for. All right, so let's start with sine. If we have a right triangle here, we're going to be working with right triangles again. And let's say A is over here. That is the angle for A. So then the sine of A is the length opposite. Notice it isn't connected to the angle. It's way across from the angle. So we have that opposite side. Again, it's not touching angle A, and it's going to be over the hypotenuse side, or divided by the hypotenuse. So let's just say, for example, we had, let's say the opposite side was 4, the hypotenuse was 5. We could say sine A equals 4 over 5. With these fractions, we always make sure we either leave it in simplest form or in decimal form. We don't want improper fractions or mixed numbers, so it needs to be a reduced fraction or a decimal. Now let's look at cosine. So again, we have that same right triangle. Let's say A is still over here. Cosine of A then will be the adjacent side, and that's the one right next to it. That's not the hypotenuse. It's the side length right next to it. So it's the adjacent side length over or divided by the hypotenuse. So for example, let's say we had an adjacent side of 6 and a hypotenuse of 11. Cosine of angle A would be the adjacent, which is right next to it. That's 6 over 11. Again, remember, you want these either to be reduced fractions or decimals, no improper fractions, and no mixed numbers. All right, let's look at tangent. So again, we're working with a right triangle. But for fun, let's just move angle A up here. Angle A is up there. We have our right triangle. Tangent is going to be the opposite side. So again, remember, opposite means what's across from the angle. Okay, you always look at where the angle is. Whatever's across from it is the opposite side. And tangent's opposite over adjacent. Remember, the adjacent is right next to the angle. It's touching that angle, but it's not the hypotenuse. And now I'm going to teach you about an acronym, a phrase. It's called SOHCAHTOA, and this is meant to help you remember the sine, cosine, and tangent relationships. Which one is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent? I just want to show you how this works. So here, the S stands for sine, and then the next two letters tell us the rule. OH is opposite over hypotenuse. Ka, the C stands for cosine. And then the A and the H is adjacent over hypotenuse. Finally, the TOA, the T stands for tangent. OA is opposite over adjacent. Hopefully this will help you remember each of the rules for sine, cosine, and tangent. SOHCAHTOA. Now this would be something that I'd highly recommend writing it for each practice problem you do, and really just continue to write it down so you'll have it memorized and it will help you remember all these. Here's a little joke about SOHCAHTOA and COSATOA and how that's not right. Go ahead and read it or skip it. All right, let's look at an example problem. So I have my right triangle, and the first thing that we are asked to find is sine of A. So I first need to identify where A is, and I can see that A is here. And I want to remember SOHCAHTOA. And I'm going to write it every time so that I remember it. For this first one, we're using SO, and let's remember that we need the opposite side. So opposite of A is 3 over the hypotenuse, which is 5. So the ratio for sine of A is 3 over 5. Now let's move on to tangent of A. So again, we're using that same angle measure, and we're looking with tangent. Tangent is TOA. So we're going to go and we're going to find the opposite. So that's 3 over the adjacent. Remember, the adjacent is right next to the angle, but not the hypotenuse. And in this case, AC, we don't know the measure of AC, but we can use Pythagorean Theorem to figure it out. A squared plus B squared equals C squared. Say I'm trying to solve for A squared. B is 3, C is 5. 3 squared is 9, 5 squared is 25. If I subtract 9 on both sides, I get A squared equals 16. Square root both sides, and I get A equals 4. Now that I have that side length, I can finish my ratio. 3 over 4. The opposite over the adjacent for tangent. Let's look at the last one here. It says cosine of B. We're using cosine, so ka, which is adjacent over hypotenuse. Now, we have to be really careful here on this one because it's saying angle B. Angle B is up here. Adjacent, remember, is right next to the angle, so that's 3 over the hypotenuse, which is 5. The ratio for cosine of B is 3/5. Now, you may be looking at this and you may be saying, Ms. Gutierrez, cosine of B is the same thing as sine of A. And you're right. That is the case because of the different angles. Okay, so sine of A is the same thing as cosine of B and vice versa. This showed you all about finding the ratios. In example 2, we're going to now solve for x. First, in example 1, we figured out how to find the ratios. Now we're going to use those ratios to solve for missing pieces. Again, I'm going to write out SOHCAHTOA because it's going to be really helpful again. Then I'm going to look at my picture and I'm going to see what I have. So I can see that my angle is here. I am given the opposite, or I have the opposite over the adjacent. And of course, we don't know what the opposite is, and that's actually what we're solving for. So if I look at SOHCAHTOA and I see which one has opposite and adjacent, that's tangent. So what it tells me is that I'm going to use tangent to help me solve for x. So remember that tangent of whatever our angle is, let's call it A, is equal to the opposite over the adjacent. Now, let's substitute in what we have. We have our angle measure, which is 28. So tangent of 28 equals our opposite over adjacent. Opposite is x. We don't know that. Adjacent was 20. Now, you may be looking at this and you may be getting a little concerned. How do we get x all by itself? This is actually really similar to when we had something like this. 28 equals x over 20. And what did we do to solve? We multiplied both sides by 20 to get x all by itself. We are actually going to do the same thing here. So I'm still going to multiply both sides by 20 to get x all by itself and clear the fraction. So we have 20 times tangent 28 equals x. Now at this point, you're going to put this into your calculator. But before you do that, it is extremely important that you check your calculator to make sure that it is in degree mode. There's another thing called radians, and we will maybe get to this at the end of the year. And basically, radians is another way to measure, but we are only concerned right now with using degrees. It's kind of like meters versus feet. They both can measure the same thing, but it's a different way of measuring. And if your calculator's in radians, you're going to get every single answer wrong. So you want to make sure that yours is in degrees. Okay? Watch the video tutorials to ensure that your calculator's in degrees. And as you're doing problems, double check. Check in the middle of a test to make sure your calculator's on the right mode, just to make sure you're calculating correctly. Again, you can pause this video and go watch some of the tutorials if you haven't watched the calculator tutorials yet. You can also feel free to ask me and I can help walk you through that as well. Okay, so let's go ahead and multiply. You're going to put this into your calculator as 20 times tangent of 28. And when you do that, you will get a number. And if you round it to the nearest tenth, it'll be 10.6 to equal x. If you did not get 10.6, my guess is your calculator's in the wrong mode. For the most part on your practice problems on your test, it'll be rounding to the nearest tenth unless the directions tell you to round to a different spot. So to recap on this problem, we solved for x, so we found a side length. Let's take a look at another example. Again, I always start with SOHCAHTOA. And yes, I want you to write it out every single time as well. We're solving for x. I can see I have my angle here, and I have my adjacent and the hypotenuse. And as I look at SOHCAHTOA, adjacent and hypotenuse is using cosine. So cosine of our angle, in this case, is 40. So cosine of 40 equals adjacent, which is 15, over hypotenuse, which is x. So now we're going to multiply both sides by x to clear the denominator. So we have x cosine of 40 equals 15. And to get x by itself, we're going to divide both sides by cosine of 40. So x is equal to 15 divided by cosine of 40. And it's really important, you guys, that you're writing all these steps out. Just in case, because sometimes it's super easy to flip the fractions on accident. And if you do that, but you don't have your work written out, then I can't help you figure out what went wrong. So in your calculator, you're going to do 15 divided by the cosine of 40. And you get x equals 19.5811 and so on. And so if we round to the nearest tenth, 19.6. This example was another example about finding a missing side length. All right, now this one is asking you to find the measure of angle A. The measure of angle A. So as I look at my picture, I'm trying to find this measure. That's our angle we're working with. And again, we have SOHCAHTOA. And as I look, we have opposite and we have hypotenuse. In SOHCAHTOA, I'm going to look for opposite and hypotenuse, which is right here, which means we are going to use sine to find our angle. So sine of angle A is our unknown, so A is going to be our variable for now, equals the opposite, which is 8, over the hypotenuse, which is 16. So now we're looking to solve for A. Yes, you could on the right-hand side, you could simplify 8/16 to 1/2 if you wanted to. But we need to solve for A. Now, if we think back to solving equations, the way that you undid addition was through subtraction. But what you were actually doing is you were taking the inverse of addition. When you want to undo multiplication, you divide. What you're really doing is you're taking the inverse of multiplication. That's going to be the same thing here. And what we're going to do to find A, or to undo that sign, is taking the inverse of sine. Now, you may in science have heard it called arc sine. Arc sine and inverse sine are the same exact thing. Now, to do inverse sine, we're going to do it to both sides. So sine inverse is the same thing as sine to the -1. That means sine inverse. And I'm going to do it to both sides. On your handheld calculator, to find sine inverse, you will hit second and then sine, because right above sine, you'll see the sine to the -1. So in that handheld calculator, you need to hit second first. If you're on your iPad calculator, there is a sine inverse button. It is not sine with an exponent of -1. You will get the wrong answer. There is a sine inverse button. All right, so as we keep solving, sine inverse and sine will cancel out, and I'll just have A. In my calculator, I will do sine inverse 8 divided by 16, and I will get. So what you're typing into your calculator is sine inverse 8/16. Okay, and your calculator actually has a really big memory and has this number stored in there. So you're just typing this in, and you're going to get the angle measure. It's 30 degrees. We were solving for an angle, so it's the measure of degrees, 30 degrees. You could check this problem by finding the sine of 30, and what you'd want to do is you'd want to make sure that that's the same thing as 8/16. 8/16 is the same thing as a half, or 0.5. Sine 30, if you put that into your calculator, you get 0.5, so it is in fact the correct answer. This example, example number 4, showed you how to find missing angles. I want to introduce you to some Greek letters that you may see and use. So the first one is theta, and it looks like this. It's like an O with a little belt. Okay. And if you think back to kindergarten, and in kindergarten, your teacher maybe wrote out a math problem like this. And they said, oh, what's the triangle? And you were able to figure out the triangle is 2. Well, then in 4th, 5th, 6th grade, instead of the triangle, they called it X. And again, you were able at that point then to realize, oh, what X is? X is 2. But if your kindergarten teacher had told you X instead of triangle, you would have probably freaked out and not known what was going on. X is a letter. Okay. Now we're bringing in some Greek alphabet because we ran out of letters. Okay. So you may see this theta. Oftentimes it's to find an angle measure, but again, theta plus 1 equals 3. You'd solve it the same way and it would still be 2. Okay, so we're introducing some more of these Greek letters as variables. Oftentimes theta will be used for an angle measure. You may also see beta and alpha. Feel free to check out this video. It's kind of a fun, catchy tune for some more help. In today's lesson, you learned how to find ratios, how to find missing angles, and how to find missing side lengths all using trigonometry. You are going to practice these three skills on your practice problems. Make sure that you read the problems carefully. Make sure that if you're stuck, you look back at your notes, you rewatch this video or rewatch parts of this video. In addition, make sure your calculator is on degree mode. Watch the tutorial to find out how to do that, or ask me.